Excellence Academy. For today, we'll be treating a very important topic in physics known as vectors. Let's treat vectors. Alright, now by physics definition, a vector is simply a quantity that has both magnitude and direction. Alright, so a vector is simply a quantity that has both magnitude. By magnitude, I mean a numerical value and then direction. Alright, examples of vectors include displacement, velocity, acceleration, force, etc. Right? Their weights and others. Right? So these are examples of vector quantities. Let's look at the representation of vectors. So how do you represent vectors? Alright. So basically, there are four ways of representing vectors. Four ways. The first way of representing vector is the use of arrows. The use of arrows, of course, in this form. Here is the first way of representing vector. Right, use of arrow. Number two, representation in the form. Let's say this is called an arrowhead. Right, placing an arrow above the vector. This is the second way of representing vector. The third way of representing vector is the use of bold-faced letters. Alright, also use bold-faced letters. This is used majorly in scientific texts, right? Textbooks and what have you. So the use of bold-faced letter or bold-faced text can also be used to represent vectors. So something of this nature. Okay. You could call this vector A in bold-faced letter. So here's vector A in bold-faced letter. If you want to, you can shade this, usually shaded. Alright, so this is a third way of representing vector. You can see it's very stressful to reproduce, and that's why this is not readily used in writing. This is used usually in textbooks. Alright, check your textbooks. Vectors are usually made with bold letters as compared to other writings. The last way or the fourth way of representing vectors is the use of caret. Right? What's a caret? That's something like this. This was called a caret. So it's called a caret placed on top of the vector. So this is the fourth way of representing vectors. So these are like four ways of representing vectors. Next up, let's look at what's called the magnitude of a vector. Let's look at what's called the magnitude, also called the modulus. Magnitude or modulus of a vector. Alright. So consider a vector given as A. So vector A being equal to AXI plus AYJ plus AZK. Let's say I have a vector in the X, Y, and Z direction. The modulus or the magnitude of the vector is given by, is written as this. So it's placed as this. So this becomes the magnitude of vector A. So when you write it, it means magnitude of vector A. So how do you get the magnitude? It's as easy as taking the square root of the magnitude of each coordinate. For the I, what here is AX, it becomes ax squared plus, for the j, what I have on the coefficient of j is ay, so it becomes ay squared plus, for k, the coefficient is az, so it becomes az squared. So this is how we get magnitude. Take the square root of the coefficient of I, j, and k, square them and sum them, of course. Take their square root. But note that if I write this one there, this means magnitude of vector A. Like I said, magnitude simply means numerical value, and that's all. Let's get an example of this. So for example, let's say I have a vector A being equal to, let's say, 2i plus 3j plus 4k, and I'm asked to find the magnitude of the vector. Of course, this means the magnitude of vector. So if I'm asked to find the magnitude, what do I do? We said the magnitude of the vector, its magnitude is simply equal to the square root of, for here, the coefficient of I is 2, so it becomes 2 squared plus, for here, the coefficient of j is 3, so it becomes 3 squared plus, for this, the coefficient of k is 4, so it becomes 4 squared. This is now equal to the square root of 2 squared gives 4 plus 3 squared gives 9 plus 4 squared gives 16. So I have this. If I sum this up, this will give me about, this is 13 plus 16. That's about 29. So I'm having this as 29. Hence, the magnitude of A is equal to the square root of 29. If you wish, you can still give this answer in decimal form if you want to. Alright, to 2 decimal places. To 2 decimal places, of course, it's not compulsory, but just in case you want to, this is about 5.39. This becomes the magnitude in 2 decimal places. It's as easy as this. Alright. Let's look at one more example when this contains a negative. So let's look at a second example. Let's say example 2. Example 2. Let's say I'm giving a vector z that's equal to I minus 2j minus 6k, for instance. Alright. So in case like this, I'm asked to find this. So find this. Alright. So without being told, we know that this signifies magnitude or modulus. So let's get the modulus of this vector. The modulus of this vector, z, will now be equal to the square root of each coefficient square. This one becomes 1. You can have it I here. The coefficient here is 1, so it becomes 1 squared plus. In this case, my coefficient here is not just 2, but minus 2. So it becomes in bracket minus 2 all squared plus, for k, the coefficient is minus 6. So it becomes in bracket minus 6 all squared. So I have this. So this will now be equal to square root of, this gives 1 squared is 1 plus minus 2 all squared gives a positive 4 plus minus 6 all squared gives positive 36. Now please be observant about this. Minus 2 squared becomes minus 2 times minus 2. Minus times minus plus 2 times 2, 4. So the same way I got positive there. This is now equal to square root of 1 plus plus is plus 4 plus plus is plus 36. If I work this out, this is equal to the square root of 1 plus 4 is 5 plus 36 gives 41. That means the modulus or the magnitude of z is equal to square root of 41. if I want to give this in 2 decimal places, this becomes equal to 6.4 or 40. That's your modulus. Approximately have 6.40, which is 6.4. So this is how you calculate the magnitude of a vector. Alright, so let's consider our next concept on vectors known as unit vector. Alright, let's look at unit vector. Alright, so of course, in most scientific or mathematical concepts, whenever you hear the term unit or unity, what comes to mind is 1. Alright, so what's a unit vector? A unit vector is simply a vector whose magnitude or whose modulus is equal to 1. That's a unit vector. Now, usually, a unit vector is being represented using a caret. Alright, so if I have this is called the position vector of A. If I have this is called the magnitude or modulus of vector A as already described. Also, if I have this is called A caret. This means the unit vector of A. Alright? Mathematically, the unit vector of A is equal to the position vector all over. So let's say the unit vector instead. So the unit vector is equal to position vector all over magnitude of the vector all over magnitude of vector. So if I take A for instance, I'll have that the unit vector of A is equal to the position vector of A all over the magnitude of vector A. So this would be the unit vector of A, right? Position vector of A all over magnitude of A. Put it. Right, so we have this. Let's take an example and see how this works. So for example, let's say I was given a position vector. Let's say M, given position vector of M has been equal to, let's say 2i plus 7j. Just this. 2i plus 7j. I'm asked to find the unit vector. Alright? Now observe that when it comes to getting unit vector, I need 2 things in getting a unit vector. I need the position vector. I also need the magnitude of the vector. So my first task would be solution. Already I've been given the unit vector M as being equal to 2i plus 7j. My next task will be to find the magnitude of M. So the magnitude of vector M, we said to get magnitude, simply take the square root of each of the coefficients of the coordinate all square. So for this case here, my coefficient of I is 2. So it becomes 2 squared plus the coefficient of j here is 7. So it becomes 7 squared. So I have this. From here, the magnitude of M is equal to the square root of 2 squared is 4 plus 7 squared is 49. This now gives you equal to the square root of these two sums up to give you 53. So I have that the magnitude of M is equal to square root of 53. If I've gotten my position vector and my modulus of the vector, I can now get unit vector. So therefore, recall that we said unit vector of M is equal to the position vector of M all over the magnitude of M. So I have this. So let's impute values and see what we get. From here, this will be equal to, this is 2i, so I have 2i plus 7j, so I have 7j all over, the magnitude here is root 53. So I have this as my unit vector. At this point, you could choose to separate them individually. That means the unit vector of M can still be expressed as equal, so you can take this over this. So I'm having 2 divided by root 53 becomes root 2 over root 53. That's I plus, I can take 7 over this, that becomes 7 all over root 53. That's J. So you can give this as a more proper expression for the unit vector. Now, is this correct? It's correct. Don't forget we said, if I'm having this as the unit vector, how can I confirm that this is correct? Now, remember we said that for this to be a unit vector, its magnitude or its modulus must be equal to 1. So if this is a unit vector now, if I have this way now, to confirm that this is a unit vector, I will take the modulus. So if I take the modulus of this one here, take the modulus of this unit vector, it will be equal to the square root of, this becomes 2 over root 53 all squared plus, this will give 7 all over root 53 all squared. Now, why this is the end of the example, we are trying to prove that this is exactly a unit vector. So this will now be equal to, if I work on this, it becomes equal to, so square to this gives you 2 square all over root 53 square. Of course, square cancels square root, it gives you 53 plus 7 square all over, of course, square cancels square root, so it's off. I have 53. So this will now be equal to the square root of 2 square is 4 all over 53 plus 7 square is 49 all over 53. Since I have same denominators, I can add them up. So it's now equal to, the square root of, I'm having same denominator here, so it becomes 53. I can simply add up numerator, becomes 4 plus 49. So this is now equal to square root of, these two sums will give you 53 all over 53. So it means that the magnitude of the unit vector is equal to the square root of 53 over 53 gives you 1. And of course, square root of 1 is equal to 1. That means this is correct. And this is where we get the concept of unit vector. If I take the magnitude of a unit vector, it will give you 1 as your answer. So this is how you solve unit vectors. So let's look at the second example on unit vectors. Now let's say I'm given perhaps the vector P as being equal to minus I plus J minus 3K. And I'm asked to find the unit vector. Now, for the first example, we used just 2 coordinates, which was I and J. In this case, I'm using 3 coordinates. So how do you solve unit vector for 3 coordinates? What do? The same idea. Of course, this is your position vector. We said to get unit vector, you need 2 things. You need the position vector. You also need the magnitude. So my first case here is to get the magnitude of the vector. So the magnitude will be equal to the square root of this one here. My coefficient here is minus 1 all squared plus my coefficient here is 1 all squared plus coefficient here is minus 3 all squared. This is now equal to the square root of minus 1 all squared gives positive 1 plus 1 squared gives 1 plus minus 3 squared gives 9. Now if you observe, when it comes to taking magnitude of vectors, when I do this, whether it's negative or positive, my answer or my result comes up as a positive. That's why in most or in some science textbooks, they won't include the minus. So you will just see 1 squared and minus 3 squared. And you'll be asking, why did they omit the minus? It's very intentional. The idea is that whether it's negative or it's positive, if I square it, I'll have the same positive result. So, no need for the stress. From here, this will now be equal to the square root of 1 plus 1, 2 plus 19. That gives you plus 9, that gives you 11. So I have that the magnitude of vector P is equal to square root of 11. Let's now get unit vector of P. The unit vector of P is now equal to the position vector of P all over the magnitude of P. Alright, so impute values. This will now be equal to, this is minus I plus J minus 3K all over the magnitude is square root of 11. Alright, so work this out. This is now equal to, I said you can choose to separate them if you want to. Alright, you can choose to separate them if you want to. So my coefficient here is minus 1 becomes minus 1 all over this square root of 11 all to I. Next up, I'm saying plus, so it becomes plus. Coefficient here is 1, so it becomes 1 all over square root of 11. Next up, J. Finally, I have minus, so it becomes minus 3 over, so 3 all over square root of 11. Next one, I have K. So this becomes the unit vector of P. Minus 1 over 11I plus 1 over 11J minus 3 over 11K. So to confirm the answer is correct, you take the square root of each of the terms square and you have 1 as your magnitude.